Hey guys, it's Remy, the math person. Today I'll be going over question 255 on SOA exam P. So pause the video quick and try this problem yourself. Okay, assuming you already attempted it, let's just dive right in. 4 letters to different insurers are prepared along with accompanying envelopes. The letters are put into the envelopes randomly. Calculate the probability that at least one letter ends up in accompanying envelopes. Okay, so at least one means it can't be, so we're looking for if n is the number of envelopes that ends up in a accompanying envelope. Probability that n is greater than or equal to 1 is equal to 1 minus the probability that 0 letters end up in the accompanying envelope, right? Okay, so this, let me write it out. 0 letters end up in accompanying envelopes. Oh, sorry, my handwriting is kind of messy, but it's okay. So what is the probability that 0 letters end up in accompanying envelopes? Okay, so imagine this. If I have a black letter, for example, it can't go into this. What is the probability that 0 end up in accompanying envelope? So if it can't go into black, it has 3 choices, right? So then out of 3 choices, we have 1. And let's say this went to, for say, purple. Then the purple letter can't go into, it still has 3 choices, right? It still has pink, black, and rainbow. So it still has, out of 3 choices, it still has 1. But let's say it goes to this one right here. Then the rainbow can't go into the rainbow because then that would be not satisfying our 0 letters ending up in the accompanying envelopes. So this rainbow has to actually go into this one. So it has no choice but to go into that one. So that's 100%. And then this one would also go in here with 100% probability. And then again, the total possible probability, because since it's we're placing them one by one. So it's just 4 times 3 times 2 times 1. So it's just 4 factorial. And you might be wondering, wait, so like, what happens if, for example, we still have, let me copy this scenario. Instead of going this way, it went, so black letters, for example, went to pink. And then purple letter went into rainbow. Then the pink and the black still has both ways to go, right? Pink can still go here. It still has 3 choices, and the rainbow can still have 3 choices too. But the thing is, like, if it goes like this or this, this scenario has already been accounted for by doing the 3 choose 1. So that's why, even though it seems as though in the surface level, because since these are arbitrary, like, it's not always going to be the black letter is going to be first. So these are just arbitrary arbitrary letters.
For example, if black goes to the rainbow, right, and the purple goes to the pink, it seems as though pink and rainbow both have 2 more choices, like this, or let's do it this way. But if I start from the rainbow being the first one, it's the same scenario, but like rainbow being the first one, and let's say the black was my second one, then pink can only go into purple, and the purple can only go to pink, so they don't have any choices but the other opposing one. So that's one of the reasons why we are allowed to just do 3 choose 1, 3 choose 1 instead of like 3 choose 1, 3 choose 1, 3 choose 1, 3 choose 1, because this scenario right here takes into consideration all the different scenarios that we all the possible different scenarios. It's just that because these are just arbitrary letters, it doesn't matter that this is the black was my first letter or the rainbow was my first letter. So these combinations just take care of all the different possibilities.
So then what is this equal to? Well, this is just equal to 3 choose 1 is just 3. 3 choose 1 is just 3. 1 times 1 is just 1. 4 factorial is 24. Right? So the probability that there is 0 letters accompanying is just 9 over 24. Okay. So then what is the probability that n is greater than 1? Well, that's just equal to the complement. 1 minus 9 over 24, which is just equal to 15 over 24, which is equal to 5 over 8, which is our answer D. If you guys have any questions, feel free to leave them down below. Otherwise, make sure you like, subscribe, and share. Bye!